Listen-only mode.
Depending on where you are joining us from, good morning, afternoon, and evening, everybody. I'm Carol Jinsei from Atlantis Computing, here with Greg Dietrich, one of our sensational architects, to do today's demo, the Atlantis USX overview and demo.
Good morning. Thank you, Carol. Good morning to the broader audience, wherever you're joining from. My name is Greg Dietrich, as Carol said, with Atlantis Computing. Today we're going to go over Atlantis USX overview and provide you a demo and really dive into how Atlantis is overthrowing that old school mentality of legacy storage, providing you up to 10 times the performance and 10 times the capacity as opposed to the traditional and legacy approach to storage solutions. Atlantis got their beginning back in 2006 and began shipping product in 2009. And this slide is a little bit outdated. Our customer count now is over 800, and our virtual machine global count is well over 800,000 as well. We also virtualized nearly 40 petabytes of storage globally, from VDI to storage, general storage offerings, database, that sort of thing. So we've got a significant footprint across the globe. Here we see an overview of some of our customers, and as you can see, we touch nearly all verticals, from education to healthcare to financial institutions, our defense industry, really every vertical we've got a footprint in. Our flagship product, Illio, really got us out there as a name, Atlantis Computing, and we've begun to morph into general storage to offer storage for VDI, to server workloads, to database workloads. USX has really taken us to the next level. So in addition to just kind of native storage growth within your organizations, many organizations grow at 10, 20, even 30% annually, but what we've seen is virtualization really driving astronomical storage growth. With the advances in physical computers, with core counts and RAM capacities within servers, we've really seen the ability to stack a tremendous amount of virtual compute within a very small physical footprint. So that's driven the requirement for additional capacity to be presented within that virtual arena. So this tremendous growth in virtualization has driven this significant growth in storage past your native and organic growth that you've got within your different organizations. So this is really where we see the industry going with your organic growth, and with the growth of storage from this virtualization push. We're seeing this 40% overall growth, which means your organization is going to double your storage needs every 2 years, and this represents a significant problem in the industry when we talk about looking at the legacy approach to storage, using spinning disk, using vast, enormous storage area networks. It really presents a huge problem, and that's where Atlantis has come in and really kind of turned the industry on its head, providing you a different approach to storage. The legacy approach to storage is you need more capacity, you're going to add more disk shelves. There's been tremendous advances in the disk technology, from 76 gigabyte disk to now we've got 2, 4, and 6 terabyte disks that we can pack into a very small amount of space. So it's always been this approach of hardware to add to solve your capacity problems. In the same aspect, needing more performance, it's been, well, let's add a flash array, or let's add a local SSD or flash cache, excuse me, on PCI card in your local servers. So again, more performance. Traditional approach is to add this more hardware to your solution. Same goes with HA and DR. If you want to have HA or DR across a WAN, then you're going to be adding replication appliances. You're going to be licensing more software to push that replication across the WAN. It's always the same approach. Scalability, whether it be vertical or horizontal scalability, it's all about adding more hardware to your current storage environment. Takes up more data center space, more power, more cooling. I'm sure everyone on the call sees where this problem is in always adding hardware to solve the storage problems. Atlantis is really here to overthrow that old school way of thinking, to really bring us into a new industry of storage approach, and that approach is software. Atlantis is 100% software. It's a software augmentation to your current environment to allow you to do those things where you're currently constrained with hardware. So we can actually come into your environment, add our software, and provide you more capacity. Take your current storage environment, actually augment that, and increase your capacity with no hardware. It's all software. In the same aspect, we can provide more performance by utilizing local resources on your server. With our intelligent software, we can provide you a significant performance increase, providing you all flash performance with no additional hardware. Same story across our HR and HA, excuse me, and DR. All of our feature set within Atlantis is offered as core to Atlantis. So any of our replication technology, our HA technology, that's all included in it. Again, it's all software. And we've got some fantastic technology that exists in the HA realm to move workloads from one location to another. And again, it's all software. Scalability, excuse me. Atlantis really provides you the ability to scale both vertically and horizontally. If you want, larger storage environment out of your current deployment, then we can do that. If we want to scale up with your growth, with your server growth, we can do that. And again, it's all a software play. Atlantis USX is software, kind of following our flagship product, Illio. So much like VMware back in the day, they brought out, they were really the forerunner of the server virtualization technology. And I kind of alluded to just a few minutes ago about the increases in CPU technology and RAM density on your servers. They were able to take and pool those resources together and return a significant density of virtual compute power. Atlantis takes the same approach to storage. So we'll take those shared SAN, NAS resources, local resources on your servers, direct attached storage. We'll take those resources and we'll pool them together, abstract them away from that hardware on the back end, and bring them up next to your application that's running within your environment. So the storage then resides on the same bus, the same compute layer as your applications, whether it be database, VDI, Exchange, email, whatever the case may be. We're able to abstract that storage away from hardware and sit it adjacent to you at the virtual layer, at the virtual compute layer. So the approach or the transformation to software-defined storage takes several different approaches. We can come in and help you augment your existing storage, your existing SAN NAS, so you can take advantage of your current CapEx investment. And we come in, we augment that, and we extend the life. We make that storage more efficient. Our deduplication technology reaches as high as 95% plus in certain situations, providing you that 10 times capacity efficiency that you really don't see anywhere else. The second kind of phase to this transformation to the software-defined storage is in hyperconvergence. So, where we really see this take over is in greenfield deployments, where a customer is deploying a new set of servers or a new data center, something like that, and we come in and take that server system with local storage, and it becomes this hyperconverged system that includes your compute layer, your storage layer, your networking layer, all within the same hardware chassis of your servers. And it really allows you the flexibility to go in any direction that you want with whatever type of server platform you want, from the lowest end commodity-based server hardware to your high-end UCS, IBM, HP, data center-centric blade technologies. So Atlantis not only offers you the performance and capacity efficiencies, but we offer you the flexibility to really head in any direction that your business desires. And at that pinnacle of this software-defined storage approach that Atlantis is driving is the ability to leverage cloud technologies for primary storage. That technology exists now for using cloud technologies. Amazon S3 is one example of that. But with that, you get these extreme latencies. So its use case is more for deep archival of storage, for data backups, and there are some vendors in the industry that do a very good job at this. Dropbox, for example, able to leverage that cloud storage. But what Atlantis can do is come in as a software play locally in your data center, communicate with the cloud, and provide this caching layer, if you will, that makes that cloud storage appear to be locally in your data center. So no longer are you fighting these 800 to 1200 millisecond response times for the cloud. You're seeing response times that are just like local storage networks within your data center, so you can begin to leverage that cheap and deep cloud-based storage. So now that I've gone over Atlantis as a company, we've talked about the different verticals that we play in, the different use cases for Atlantis, covering extending the life of your current capital expenses to hyperconverged and even into cloud. I'm going to talk a lot. I was going to say a little bit, and we're going to talk a lot about Atlantis USX at its core. What is it, and how does it accomplish this tall task that we've talked about? So at the very foundational layer of Atlantis USX is storage. We've talked about it. It can be shared SAN NAS storage. We can use resources that are local to your server, local hard drive, spinning disk, memory, flash, really anything locally to that storage, as well as direct attached storage. And then that extends out to cloud storage. So at the very foundational layer is our ability to consume, pool, and abstract that storage away from the hardware. We optimize it within our data services layer and provide it back to you as a data store within your virtual compute layer. So we live on top of your hypervisor, and currently that hypervisor is VMware or Zen server with other technologies on the very near roadmap. So we live on the hypervisor, and we consume resources away from the hardware and provide it right back to you in an optimized, more efficient manner. And that's where our data services come into play. So our foundation being the abstraction of storage. Next would be our data services, our HyperDup Content-Aware Data Services. And this is really at the core of Atlantis as a company, Atlantis as a product suite, from our very beginnings with our flagship product Illio to our current shipping product USX. Data services is the core. And where this all began back with our founders was how do we commit I/O to disk as fast as possible? And we found that the best way to do that was to ignore most of it. So by introducing deduplication in the performance layer in the memory or local solid state, by introducing deduplication inline in memory, we're able to reach deduplication statistics that are industry best. We're able to hit performance that, up to 10 times what you would see out of traditional legacy rotating disk, cloud storage, etc. So as you write data to your data store that you've offered up from USX, we ingest that and we deduplicate it inline. So before it ever hits rotating disk, flash disk, cloud storage, before it ever hits that level, it's deduplicated and compressed. And the only thing that gets committed to disk is unique data. So all this is taking place in memory in our performance pool. So all deduplication, compression, this entire data services layer is within memory before it ever hits disk. And this really sets us aside from the industry. Other types of deduplication are post-process deduplication, which are very efficient, but you have to have the overall capacity sitting there because it's a post-process. So the data gets written, and then there's a process that runs in the background that deduplicates it and shrinks it. Good technology is just post-process. And then we've got, the other part of the industry that's in line at the storage controller. Well, that means that your data still needs to leave that virtual layer, that virtual data store layer, and traverse across your network. So it's in line at the storage controller. What Atlantis offers is inline deduplication compression at the compute layer in memory. And this whole process seems like it would be resource intensive. It's really not. And this is where all of our IP lies. This is where all of our patent pending, our awarded patents lie within this layer. So that timeline is really measured in the microseconds to accomplish this. And at the core of everything we do, and I know I keep repeating deduplication, and you'll hear this message throughout the presentation, it is at the core of really everything we do. So in addition to those data services that I've talked about is this I/O acceleration. So as we ingest data, we're not only deduplicating it, we're holding those unique blocks in memory as well as putting them to disk. So when you need to read from those blocks that are duplicate, you read right out of memory, right out of that caching layer. So we're not necessarily a tiered approach. we like to think of it more as a pooled approach. So you have a performance pool and a capacity pool, and that performance pool acts as this caching layer that coalesces the I/O into very serial known block increments before it's ever committed to disk. So this avoids that whole I/O blender effect that you get from VDI environments where it's just completely random I/O that's read and write. Our data services layer allows us to cache that and coalesce it into a more streamlined committal to disk. In the same services layer, and keep in mind that this is still all within memory and this is still all within the microsecond type of response, is our ability to provision. And we've got a technology called fast clone, and I'll show you that here in a demo coming up. But that our fast clone technology allows us to take a virtual machine or a virtual machine template and clone that out in a very, very fast way that's presented to your hypervisors as full clones. So we're able to go in and clone 10, 100, hundreds of VMs in a very short amount of time in a very capacity efficient manner. That same technology of cloning is based upon deduplication. That extends out to our teleport technology, which allows us to move virtual workloads from one data store to another in a deduplicated and compressed manner. So regardless, and we'll go into that later, I don't want to get sidetracked, sorry. So as you can see, our data services and the breadth of our services are all based upon that deduplication technology where all of our patents lie. And this really offers the largest suite of data services in the industry that allow your businesses the flexibility to provide storage really to any use case, whether it be VDI, database, file print services, virtual server workloads, whatever the case may be. Atlantis USX offers you that flexibility. So bringing USX into your environment, this is the how Atlantis can benefit you. Leveraging your current capital expense, we can come in, act as a software overlay to your hypervisor, and provide you 90% capacity efficiency. So we can reduce your current storage footprint by 80 and 90%, which would take, if we step back and we look at that 40% number that we talked about a little bit earlier, we can, based upon that 40% number, if we can reduce your capacity and make it more efficient up to 80 and 90%, we can extend the current life of those capital expenses, those assets, out multiple years. So we're not necessarily coming in and displacing your SAN or your NAS. We can come in and we can augment it, make it better and more efficient. We can take that performance pool that I spoke about, and we can put that in front of the 7.2K RPM drives and make it seem like an all-flash type of capacity. And that's just by putting our software in front of it, utilizing local resources that you already have on the servers, whether it be memory or solid state. Leverage that to drive this all-flash performance out of your legacy rotational disks. From a new storage perspective, we talked about this a little bit earlier, and this is the idea of complete hyperconvergence. So we can come in alongside of your new server deployments and help you architect these servers such that we can sit there with your hypervisor utilizing local resources on the servers, either a single server or multiple servers in a cluster, and we can pool all those resources together and offer storage that is enterprise level, enterprise protected, RAID protected from your servers as a complete hyper-converged solution. And this is really an exciting story to a lot of companies that are targeting VDI for their deployments. This allows us an extreme performance level out of very little storage. You know, I talked earlier about the compute layer and how CPU technology and RAM technologies have really allowed us to get to the next level of density for your virtual compute layer. What we do is we also leverage that compute layer, those advances in CPU, to let you start to run your own storage controllers through the Atlantis software. You're basically virtualizing your storage controllers, your storage fabric, your storage RAID. Everything is virtualized within that USX stack that sits right there nice and neatly on top of your hypervisors, utilizing the advancements in technology from your CPU and your RAM assets. So this is why our technology is important. And here with this red line, you see this increase of, let's say, 100 terabytes, increasing as we identified before at 40%. By the time we hit 3 to 5 years, that 100 terabytes of capacity has grown to nearly 500 terabytes. And that capital expense becomes significant. So just by bringing USX Atlantis in day one, putting us in front of that 100 terabytes reduces that footprint to more like 20. So you can take that same 100 terabytes, and by using our capacity efficiencies, our deduplication technology, you can take that 100 terabytes and you can stretch the life of that out 3, 4, and 5 years, you know, based upon your growth. We can stretch that out and make the lifetime of that SAN or NAS technology stretch out significantly. In the same aspect, you're saving that capital expense between that 100 terabytes and 500 terabytes. You're saving that capital expense of nearly $2 million, and you're pushing that out significantly just by introducing a software layer on top of your current assets. Moving past that 100 terabytes, then, instead of adding another storage array, another SAN technology, adding in a flash SAN technology, we can extend that current 100 terabytes just by adding locally attached DAS arrays. You know, we can bring that into the existing environment and offer that single pane of glass management that we all enjoy just by adding direct attached storage on the background. Then let's bring in that cloud capacity that we talked about a little bit earlier with our cloud connector. We can make that cloud storage look as if it were sitting within your data center. So now extending the life of your SAN by 3 to 5 years, and then adding more capacity just by adding local attached storage, extending that out into cloud capacity. You can see here how your storage environment is as flexible as your business, and you can really drive it in any direction that it needs to be, that it needs to go. So at this point in time, I'd like to jump into a demonstration to kind of show you some of the technology that I've been speaking about for the last few minutes. Carol, do we have any questions that are current before I move on to the demonstration?
Actually, not at this time. We will go ahead and wait for the end of your presentation to take care of all the questions.
Okay, great. Give me just a second to bring that over. So here we've got the USX manager, and my session is probably timed out, so I'll log back in. So our USX manager is the central administration pane for everything USX, from deployment to monitoring and alerts to analytics and even to HA. Our USX manager is at the core of managing that entire environment. That's not to say that the environment is dependent on the USX manager. This is merely a management interface, and it can be rebooted. It can be vMotioned off to another hypervisor for maintenance. But this is at the core of managing your USX environment. So let me show you what a typical kind of deployment would consist of. Here you see we've got service VMs, and those are the consumption nodes that I spoke of earlier, how we pool and abstract the storage. The service VMs are what we use to accomplish that. So they're deployed to each one of the hypervisors, and they use those local resources, pulling them away from the hardware and bringing them up into that performance pool, that memory layer that allows us to get that significant performance, that allows us to do the deduplication, compression, coalescing. All of our data services that we talked about is because we pull those resources away from the hardware. Then here you see volumes. Now volumes is equivalent or synonymous with data store within VMware. Now, of course, I'm using VMware here, but we also work currently with the Xen platform, and KVM, Hyper-V are on the near roadmap. So these USX volumes represent a data store, and this is basically just a VM that's running services that control that I/O in and out of that pooled and abstracted storage. So by separating this layer of USX, we're able to really take advantage of HA, of vMotion technology to make this volume presentation very resilient. So we've got these two layers, this USX service VMs, which are your pooling and abstraction layer, and then we've got the presentation layer from our volume VMs. So that's what it looks like at a 10,000-foot overview. So when we first deploy the USX manager, you would be presented with 5 very simple steps on setting up the environment. And that's represented here. So the first thing we would do is we would come in and we would add your VM manager. And your VM manager is your vCenter or your master server within the Xen platform. So we can add as many of these vCenters, Xen servers as we need to manage your environment. So you see here I'm connected to one vCenter, which then allows me to manage the hypervisors from a USX perspective. And that's the next thing you would do, is identify those resources on your hypervisors that you want to leverage for your storage. So based upon the preferences that you set within this interface, it exposes 50% of available RAM here, which we see out of this 12 gig. That's representative of what we've set in our preferences. And then our interface here also exposes the local storage that's available in each one of those, as well as the shared storage. We don't have any shared storage in my test environment, so it's all local storage. So you see here how my ESX servers have solid state and traditional legacy storage. And I've selected to use just the hard drives, just the legacy disks on each one of the hypervisors. So here you see I've got almost 200 gig, 170, 150 gig available storage for my USX deployment. The next we would do is come in and build network profiles. So the network profiles are for storage traffic, which is essentially your storage fabric. You know, much like a traditional SAN approach has your fiber channel network or your converged network or FCOE, whatever the case may be, we still utilize that, but we leverage your virtual resources, your virtual network, your connectivity between your hypervisors. We use that as our fabric. So this is where we would define those networks. And currently we are an NFS or iSCSI data store target, so everything here is IP based. And we do have other technologies on the roadmap for object store and SMB presentation for our data stores. So two different types of network we would require for a production. It would be a management network and a storage network. Like I said, storage network would be your storage fabric, and the management network is how we manage all the individual pieces here. Then we've got name templates that include volume naming, service VM naming, and fast clone. And you'll see fast clone here in just a few minutes. And the last thing we have to do is to create a volume. So through this volume configuration wizard, we can create, this is where kind of our policy-driven management of USX comes into play. We can create volumes from your existing resources on your servers, whether it be, you know, RAM or flash or spinning disk. We can create storage out of those assets and even shared storage to provide for VDI or database. And, you know, in database deployments, you've got log volumes, and you've got, you know, your volume that's there for your database backups, and you've got your primary storage for database. You could take the same approach with USX, offering up different data stores by the different types of data store that you deploy. So from our very simple deployments, and simple is just a label. By no means is the technology simple. The simple deployments mean that it's a one-for-one relationship. It's using one hypervisor, one server for that deployment. And we really see a lot of VDI deployments in this area. You know, stateless VDI is going to use our simple in-memory technology, and that's going to allow them this ultra-fast, ultra-responsive volume for VDI deployments. Simple all-flash would be more towards your persistent VM technology, persistent VDI technology for your VDI deployments. Simple hybrid is going to leverage shared storage that's attached to your single hypervisor and provide you that all-flash type of performance using our performance pool out of that legacy back-end SAN NAS technology. So in the same aspect that we do with the simple technology, which is a single hypervisor, we can do across clusters of servers. So in that instance, like you saw in our vSphere interface, we have 3 service VMs. Those are abstracting those resources away from the hypervisor, and they're RAID protecting it. And that's why the minimum requirement for a clustered USX approach would be 3 servers, because we do have to RAID protect those discrete local resources. So we can create, you know, volumes that are very similar to the simple, but in a clustered approach. So hyper-converged would be all local storage, and you know, we talked about that being kind of the second phase towards this software-defined storage initiative. And then hybrid would be during that first phase where we want to leverage those existing assets that you have. We want to make their life longer. We want to make them more efficient. That would be a hybrid approach. And then the all-flash and in-memory all-flash can either be local in a hyper-converged model, or it can be in a shared SAN NAS leveraging like an IBM all-flash array or an Extreme IO brick. We can sit in front of that, and we can make it faster than it is natively because of the deduplication that we do inline in memory. All of your acknowledgments for duplicate writes would be coming right out of memory, and you'll also see that a little bit later. So that's our volume technology. So remember, I talked a lot about deduplication, and I know I tend to really hound on that term, but it really is at the core of everything we do. So here I want to show you we have two data stores, two volume VMs, volume 1 and volume 2, and we can see that by looking at the data stores and clusters view. Here's our two data stores. They're both exactly the same size. They're 50 gig presentations, so it's 49 gig usable. And you see here this has 4 virtual machines and templates. Both of these started out exactly the same with 4 virtual machines and templates, identical. What I did before this presentation is I did a fast clone of 10 virtual machines in volume 2, and I'll show you that here in a minute. And you'll see here that now my provision space is 266 gig out of just 49 gig of capacity. And that's evident here in our USX manager, where we look at these volumes and we see that volume 1 is 14% capacity used at 97% deduplication. Well, if we look at volume 2, we're still at 14%, but you see how the deduplication ratio kicked up. That's because our ratio just gets better as you add more to it. So let's go back to the vSphere interface and look a little bit more at that. So we look at the first volume. We've got 46.37 gig free space of that 49 for 4 VMs. We look at the volume 2, which has got 10 more VMs, and we're only 46.33 gig available. So it took 0.04 gig of storage space to us to provide full clones of each of those VMs. So here's our fast clone VMs, and there are the full clones of those CentOS VMs. So let's go through that process here. So we'll go to our volume 1, and we'll fast clone out one of our templates. And again, deduplication is at the core of this technology. So we'll select any of our powered off VMs or our templates, and we'll fast clone that out. Let's do another 10 VMs, and we'll select our fast clone template. And we go over to our vSphere interface. I'm going to change over to our VMs and templates interface. And you see here how these are the original, these VMs here are the original VMs, VM 1, 2, and 3, as well as your template. And these are the fast clone copies that I made before our presentation today. Now we see here these virtual machines being registered. And this is the fast clone process that I just kicked off. So we had originally our 3 core VMs with our template, and now we've got 10 VMs populating here. This process here, so this environment, this test environment, is a multi-tenant kind of shared environment for our SEs across the globe. In a production scenario, we've seen this fast clone process take as little time as 4 seconds per virtual machine. I don't know if you're aware, but our recent hyperscale launch that we had, there's a demonstration of one of our SEs doing this fast clone process, 100 virtual machines with an average of 4 seconds per virtual machine. So now we go back over to our data stores and we refresh our data store. So we've got 46.37 gig available initially, and now we're at 46.33, and this 78 gig, this will catch up. There we go. So we've provisioned nearly 300 gig in about 3 gig of space. So we go back over to our USX manager where our process is complete, and we'll go back to our USX volume 1. Let's go back to our management interface here. and you'll see that our capacity used is still only 14%, but now the deduplication ratio has gone up to 99%. And we can leverage that same technology in our teleport and our backup features. And we'll go into that here. So that's a little bit of a demonstration of our, our USX manager and a little bit of our technology. So this is very similar to what you just saw within the USX manager. We've got our multiple hypervisors that exist with our service VMs and volume VMs that sit on top of those hypervisors, providing you space for your guest VMs. And this animation kind of shows you what losing an entire hypervisor, you would lose a service VM, but because of our RAID protection, your data store stays completely intact. So our ability to create that software RAID and a clustered approach allows resiliency at the hypervisor level. And I want to touch a little bit on teleport before we open the line for questions. So teleport is probably one of my favorite features of the USX platform, and it's because of my life as a VM farm administrator, where I can take a virtual machine from Data Center 1 that's got, let's say, Windows 2008 server running. I can then teleport it to a different data center, even though it's never seen that specific VM before. I'm going to deduplicate it based upon what that data center or that data store already has. So if it's also got Windows 2008 servers running in it, 95% of that VM is exactly the same. I'm only going to replicate the deltas, the difference between that Active Directory server and, let's say, a 2008 web server. So teleport becomes very important and very critical to moving workloads from data center to data center and even into the cloud. So on the business side of what USX can bring to your environment, so everything is measured in the storage environment. It's measured in IOPS and capacity, and there's a price associated with that. And in this slide, you can see here how the traditional SAN-NAS approach, has a fairly cheap cost per gigabyte, but a significant cost for IOPS. And then with the introduction of the all-flash array, we get into a cheaper cost per IOP, but a more costly cost per gigabyte. With Atlantis sitting in front of any of that technology, you can see here how the cost per IOP drops significantly, and I'll show you where that 0.05 comes in, and the cost per gigabyte also drops. So in a recent test we did with IBM servers, we used their flash on DIMM technology to virtualize nearly 100 terabytes of storage across 3 servers. So with our software on top of the hypervisor, we're able to abstract that flash on DIMM technology away, put the data store on that technology, and across 3 servers drive 3.3 million IOPS. And from my storage background, that's not as impressive as the milliseconds latency. To me, the story behind storage is all about latency and the reaction time of your storage. And to be able to drive 3.3 million IOPS with merely 1.15 milliseconds latency is nothing short of astounding. So this is where we get into kind of that 5 cents per IOP discussion. So taking that same platform and benchmarking using the TPCC benchmarking, which is the Transaction Processing Control Board. They've got this HammerDB benchmarking product where we were able to drive 1.7 million transactions per minute off of that same type of deployment. So previously, these are like the top 7 within their rankings. And you see here Cisco UCS with a Violin backend was, the award winner, 1.6 million transactions at 47 cents. Well, we were able to come in at more performance but significantly reduced price. And why is that? We were able to accomplish that across 4 super micro servers using Atlantis USX and the hypervisor. You see the specs here on the servers, but we were able to drive that 1.7 million IOPS with $82,000 capex versus a Cisco UCS in front of Violin storage array back in that was at 47 cents per transaction. I know I skipped a few slides, but I want to make sure that we allow enough time for questions, and we are shortly running out. So I'm sure you've all heard the buzz in the industry about hyperconvergence, and what you're beginning to hear is Atlantis telling that story. From our flagship product Illio to our USX general storage, VDI, database, whatever product, hyperconvergence and Atlantis are starting to become synonymous in the industry. So, you know, I've gone over a lot of our technology, given you a short demonstration of what our technology is all about. And so the key takeaway here are the use cases where you can actually leverage the power of Atlantis USX to fulfill your performance and capacity needs in your data center. 100% software, and our deduplication, our patented deduplication technology is really at the core of everything we do. So with that being said, I know I rushed through the last couple slides, but I wanted to make sure you got a good demonstration of what we could do.
Thank you, Greg. And right now I'll go ahead and read off some of the questions that came in. The first one is, do you have any customers using Atlantis with VMware View and Tin Tree storage?
Yeah, so we have customers running VMware View on multiple platforms. I know I skipped through the slide, but we sit side by side with any storage platform. The slide I skipped was with Nimble Storage, showing the difference between 5,000 IOPS and 20,000 IOPS. So the back-end storage is really, I would say, unimportant, but we're hardware agnostic. So while I can't say Tin Tree specifically, I know that we sit in front of a vast majority of different technologies. As long as the hypervisor can see it, we can leverage the power of it.
Okay. The next one is, are you able to do any compression on video files? NetApp was unable to do this for their company.
So video files inherently are very difficult, as well as picture or image files are very difficult to compress. So our compression technology does happen in line, and we'll compress where we can. I think that's an important question that maybe we can follow up with offline and get one of our engineers, one of our backshop engineers involved to kind of give you an idea of how well we can do that.
Okay. Does the HyperDup feature work retrospectively once installed, or is it from the point in time moving forward?
So it's going to be the point in time moving forward. So we do have to consume the data to build our metadata, to build our cache, and to get that deduplication percentage that you're striving for.
Okay. And Greg, we have a request of you to go back to the slide. We have a gentleman who uses Nimble Storage, and he would like to see that again, please.
Okay. My apologies for going through that. I was trying to be cognizant of the time. So this is one of our case studies at Northrim Bank, where they were having capacity challenges, as most people who engage Atlantis are. They have EqualLogic and Nimble arrays, and by bringing in USX in front of both, they were able to pool those technologies together, put USX in front of it, and provide, according to Eric here, 10x the increase in performance. So here's kind of a graph of what that looked like between only Nimble, with the workload profile identified at the bottom, and then Atlantis USX in front of Nimble. you can see that IOPS, latency, and throughput to disk are all enhanced by the introduction of Atlantis USX. I hope that answers your question.
Okay, next one is, someone has a block data SAN.
Okay.
Did you say that NAS, NFS was the main market for Atlantis, or the only technology? They have SAN using block data. Is that technology compatible with Atlantis?
Absolutely. So if I didn't get the idea across well enough, my apologies. But we can consume storage of any fashion as long as your hypervisor can see it, we can leverage it. So whether it's vVol, whether it's vSAN, SAN storage, block storage, file storage, whatever, we can consume it, optimize it, and present it back as an NFS data store or iSCSI currently. So that's the mounting protocol used for accessing the data store.
Okay. Can a performance gain be obtained when you're already using flash storage?
Yes, it can. So because of our inline deduplication, you don't have to write everything to flash. So we don't have to traverse any kind of network, anything to get the performance. So we're able to leverage the performance of your flash. We put our deduplication technology in front of it, so now your acknowledgments for duplicate writes are coming right out of memory as opposed to off your flash technology. So with flash, you're getting capacity efficiency that is up to 10x as well as a performance increase. You probably won't see the 10x performance increase out of a flash and USX in front of flash, but you will see a performance increase.
Okay. Does Atlantis take over the storage controller? For example, the Nimble storage controller will need to be replaced in 3 years. Would we be able to skip this replacement?
So if we are leveraging Nimble storage for our capacity pool, we can move the workload off of that data store to a different data store to allow you to upgrade your Nimble. But keep in mind, we are utilizing your raw lungs, your NFS presentation to the hypervisor for the efficiencies you gain with USX.
Okay. So this one, they don't have any flash or SSD drive on our SAN or internal storage. What can Atlantis do for their company in this case?
So in that instance, what we would do is deploy across your hypervisors, whether it be a single hypervisor or a cluster, and we would consume local memory resources and build a deduplicated pool of storage out of those memory resources, accelerate the I/O using those resources while leveraging your back-end storage, your 7K or 10K, whatever disks you have in the back-end for capacity and persistent storage.
Okay. And then, how does deduplication affect the ability to backup and restore virtual machines?
So we work in concert with technologies like Veeam and Data Domain. They see us as a standard hypervisor data store, so they're completely unaware of what happens in the background. So backup technologies remain along the same approach.
All right. Thank you, everybody, for attending this morning's webinar. You will receive a special link shortly after this with the recorded session. If you decide to share it with any of your colleagues who would like to view it again, you can find that in that recording. Thank you again, and have a good rest of your day.
Yeah,
Bye.
thank you for your time.